In this video, we're going to prove lines parallel. And a couple of videos ago, we talked about parallel lines cut by a transversal, corresponding angles were congruent, alternate interior and exterior angles were congruent, and then consecutive same side interior or same side exterior are supplementary. So we're going to use the converse of those. And remember from Unit 1, the converse is where we switch the hypothesis and conclusion. So now we're going to say that if two lines cut by a transversal so that corresponding or alternate interior or alternate exterior are congruent, then we're going to prove those lines are parallel. So whereas before we were given the lines are parallel and we proved angles congruent or supplementary, we're going to be going in the opposite direction. So if I'm going to use the corresponding angles converse to prove the lines are parallel, I would have to identify some corresponding angles. So for example, angle 2 and angle 6. And angle 6. I could also say angles 3 and angle 7. Or angle 1 and angle 5. Or angle 4 and angle 8, because these are all the corresponding angles. And if these angles are congruent, then the lines are parallel. The alternate interior angles converse, well, if I'm going to prove that the lines are parallel, then I'm going to show that alternate interior angles are congruent. So angles 3 and 5. Or angles 4 and 6. Because they are on the alternate sides of the transversal and they are inside the interior region of the parallel lines. The alternate exterior angles converse, we need to show that angle 2 and angle 8 or angles 1 and angle 7 are congruent. In the consecutive same side interior angles converse, well, I would need consecutive interior angles such as 3 and 6. If I could show that those are supplementary, then I could prove that these lines are parallel. I could also use angles 4 and angles 5. And the same side exterior angles, okay, so let's take a look. Same side exterior. So how about 1 and 8? If I can show that those are supplementary, then I can prove the lines are parallel. Or I could also use angles 2 and angle 7. There's one more theorem that's not on here that we need to list, and that's the perpendicular transversal theorem. If a line is perpendicular to one of two parallel lines, then it is perpendicular to the second line. Let me show you what I'm talking about. If I have two parallel lines, and I'm going to mark them with the little chevrons, so I know that these lines are parallel. If I have a transversal that is perpendicular, that means it intersects at a right angle on the first line, and this is to the parallel line, then it is also perpendicular to the second line. And so that's what that theorem is stating. Okay, so now let's put this to practice. It says, given the following information, determine which lines, if any, are parallel. State the converse that justifies your answer. And I'm going to go ahead and abbreviate. Corresponding angles converse, corresponding angles converse, alternate interior angles converse, alternate exterior angle converse, same side interior angles converse, or same side exterior angles converse, just so you know what I'm talking about. All right, so let's take a look. If I know that angle 2 is congruent to angle 4, angle 2 is congruent to angle 4, I can say that line C is parallel to line D because these are corresponding angles converse. Angle 5 is congruent to angle 10. So let's see, 5 and 10. We can see that these are on alternate sides of the line. So line A is parallel to line B, and this is the alternate interior angles converse. These are on opposite sides of this transversal. These are the angle pairs, so these are the parallel lines. All right, the measure of angles 6 and 10. So now I'm looking at 6 and 10. Let's see. All right, so we've got same side interior. This is my grouping and this is my grouping, so these are my parallel lines. A is parallel to B, and these are supplementary. So this is same side interior angle converse. All right, let's take a look at the next. Measure of angle 1 is congruent to angle 14. All right, so I'm looking at 1 and 14. All right, again, here's my grouping and my grouping, so I'm showing that A and B are parallel. And let's see, I had 1 and 14. What kind of angles are those? Well, those are alternate exterior angles, and that's the converse to prove that the two lines are parallel. 14 and 15 add to 180, so let's take a look at those. 14 and 15. All right, so these are same side interior, and the two groupings would be this guy and this guy. So we're proving that C and D are now parallel because angle 14 and 15 are supplementary. Those are same side interior angles. Converse, if they are supplementary, the lines are parallel. The next example, 11 and 16. All right, let's take a look. 11 is right here, is congruent to angle 16. Well, we know that these are congruent because they're vertical angles, but they don't prove any lines are parallel because they're in the same grouping. So we can just say that these are congruent because they're vertical, but they're not proving any lines are parallel. Okay, let's take a look at the next one. Angle 4 is congruent to 15. So 4 and 15. Okay, we've got two separate groupings. So I can say that these are my parallel lines. A is parallel to B. Now those angles 4 and 15, they're on the opposite sides of the line, so they're on alternate sides of the transversal, and they are exterior. So this is the alternate exterior angle converse. Okay, angles 10 and angles 12. Let's look at those. 10 and 12. Okay, so if those are congruent, I've got the two groupings here and here. That's going to prove C and D are parallel. And they are corresponding. So this is the corresponding angles converse because they're in the same position on each of those groupings. Measure of angle 9 plus 13 is 180. Okay, so we're looking at 9 and 13. All right, do we see that they are on the same grouping? So again, this is none. You have to be on two different groupings. And all we can say is that these are a linear pair. Here's the straight line. They add to 180. They're a linear pair. All right, in the next example, 2 is congruent to 7. Okay, here's 2 and 7. Two different groupings. So two different lines are parallel. C is parallel to D, and 2 and 7 are alternate interior angles. The converse proves the lines are parallel. And our last example, 6 is congruent to 11. Okay, let's try 6 and 11. Okay, so 6 and 11 are not on the same transversal. Okay, angle 6 is either going to be on this transversal or this transversal, and angle 11 is going to be either on this transversal or this transversal. So I can't prove that any of the lines are parallel because they're not on the same transversal. So not cut by the same transversal. Okay, let's go through a few more. Angle 9, congruent to angle 22. 9 and 22. I don't even see a 22. Oh, this guy right here. All right, so we are in two different angle groupings. Here's the transversal that connects them both. Here is my interior region, so I know that these are alternate exterior angles. And I'm going to prove that Q is parallel to R by alternate exterior angles converse. 8 and 13. Angle 8 and angle 13 are supplementary. Here's the transversal that connects the two different angle groupings, so P and Q. P is parallel to Q, and P is parallel to Q, and this is same side interior angles converse. Okay, next, angle 1 and angle 17. 1 and 17. Okay, so here's the transversal. Here are my two angle groupings, so P and R. P is parallel to R, and these are 1 and 17 corresponding angles converse. All right, letter D, 16 and 20. So 16 is here, 20 is here, and let's see, we've got two different angle groupings, so that's good. Here's the transversal. That's good. So Q and R. Q is parallel to R, and these are alternate interior angles converse. All right, the next one, we have 5 and 24. 5 is up here. I gotta always mark them so I can see them. 24 is down here. This is the transversal that connects them. This would all be the interior region, so these are going to be alternate exterior angles converse, and they prove these two lines are parallel, P and R. All right, next up, we have a measure of angle 4, and 17 is 180. So let's see, here's 4 and 17. All right, just pretend this isn't here. Then we have P and R are parallel, and this is same side interior angles converse. Because those are supplementary, those lines are parallel. P is parallel to R. Next up is 10 and 13. Angle 10 and angle 13. Okay, so angle 10 is congruent to angle 13. And let's see, this would be the transversal. We're in two different lines. We're in two different groupings. Okay, and so let's see on this one, we can say that S is parallel to T. And the perpendicular transversal theorem is what we're going to use to justify. So S is parallel to T. And I'm going to back up on that one because I'm going to come back to that one. Let's think about that one. 10 is congruent to 13. I've got my transversal. Okay, even though they don't look it, if we know that they are congruent, then this is Well, that doesn't prove anything, because if they were same side interior, they'd have to be supplementary. So I'm going to say that none. These are not parallel lines, because same side interior have to be supplementary. Sorry about that, guys. Sometimes you got to stop and think for a minute. All right, angle 3 congruent to angle 22. All right, got to slow down and really think about these sometimes. 3 and 22. Okay, so here's the transversal, and I've got the two groupings. These are in the same position, so I'm going to say that line P is parallel to R for the corresponding angles converse. Okay, 15 and 5 are up next. Let's take a look. Angle 15 is this guy, angle 5 is this guy. Okay, first thing, here's the transversal. They are in two different angle groupings, and they are alternate exterior of this interior region. So I can confidently say that P and Q are parallel, and this is alternate exterior angles converse. All right, and then my last one, the measure of angle 11 and 16 are 180. Okay, so I now I'm looking at some supplementary. 11 and 16. Okay, here's the transversal. 11 plus 16 are 180. So same side interior angles are going to prove that same side supplementary angles are going to prove that S is parallel to T. This one we're confident about because of the same side interior angles converse. They might not look it, but if those two are supplementary, then our two lines are parallel. Okay, complete the proof below by filling in the missing reasons. 4 and 5 are supplementary, so this guy plus this guy are supplementary. That's what's given. Let's prove that J is parallel to K. Well, they are on the same transversal, and they are in two different angle groupings. So if they are supplementary, well, this is our given. This was given to us. So that is the reason for that first statement. And if they're supplementary, that means they add to 180. So the definition of supplementary. And we can prove that J is parallel to K because these are same side interior angles converse. Identifies that those two lines are parallel if those two angles are supplementary. And our last proof, angle 1 and 2 form a linear pair. Okay, so angles 1 and 2 form a linear pair. That's given. Angles 1 and 4 are supplementary. So angles 1 and angle 4 are supplementary. And same side exterior angles are supplementary. And so let's see. Oh, but our second statement was 1 and 2 are supplementary. That's just the definition of a linear pair. Let me stop myself there. Okay, I was looking at this next statement now. 1 and 4 are supplementary. This is given information. So angle 2 is congruent to angle 4. Okay, so this is what we call the transitive property. And what it's saying is if 1 and 4 are supplementary, then 2 and, okay, that means that these lines are parallel by corresponding angles, converse. But if these two are supplementary, then angles 2 is going to correspond with angle 4. They're in the same position on each of those angle groupings. And we will definitely spend some more time practicing